in 5.1. Good. So we have the for x equals 3, so these two. The formulas are, so the consumer surplus is the integral from 0 to 3 from this function, 0.425 x squared minus 5.7 x plus 22.5 dx minus 3 multiplied by d of 3. So I have to find d of 3 and multiply 3 by it. So I go to the graphing calculator, I insert, let me clear, I worked with another class on something else. So we have 0.425 x squared and then minus 5.7x and then plus 22.5. And then all I need is to plug in 3. Let me look again. 0.425 x squared plus 22. Yep, everything is okay. Did I copy the function correctly from the book? Let's see. 0.425 x squared minus 5.7x plus 22.5. Okay. And the other one, 0.3x. Yes, plus 5.3. Okay. I'm going to go back and also put in the supply function. 0.3 x plus 5.3. Okay. So we have 9.225. And we produce a surplus, which is 3 times 6.2 minus the integral from 0 to 3 from the other function, 0.3x plus 5.3 dx. With your permission, I'm just going to enter these in the graphing calculator. So I'm going to try to do something here and see if this is going to work. So this was from 0 to 3. And here we have, I'd like to call the function. I have this function in y1. Let me see if I can call the function if it's going to work. I've never tried this. Okay. Dx. And then minus 3 multiplied by 9.225. Okay, so I got $18. So the other one is 3 multiplied by 6.2 minus the integral from 0 to 3 again. And now I'm going to call function 2. No, that's not what I meant. Okay, and dx, and this is the producer surplus. The producer surplus at the given point. Okay, so I got 1.35. And now they're asking us to find the equilibrium point. So in order to find the equilibrium point, I have to set d of x set equal to s of x. So I have 0.425 x squared. Is this okay so far? Any questions? Let's stop for a moment. Is this okay so far? Oh, nobody can see anything. Oh, nobody can see it. No, you were not able to.
We can see. We saw it. The paper.
Oh, you see? You saw that?
Yes, the paper was on.
Yeah, for some reason I changed the view somehow. Speaker, multi-speaker. I don't see my writing anymore. Okay, I got it. I see it now. Good. So I set this equal to each other. So I have 0.425 x squared minus 6x and plus 17.2 equals 0. Because I have to move these to the other side, they become negative. So 22.5 minus 5.3 is 17.2. And when I move 0.3, it becomes negative. So negative 5.7x minus 0.3x is negative 6. Don't do anything, just put in the graphing calculator to find the solutions. So we go to apps, and that's number 9. And this is a polynomial degree 2. First coefficient, or the leading coefficient, 4.425. The next coefficient is negative 6. And the last coefficient is 17.2. And we will only select the solutions under 6. We are told to do that. So then x equals 4. So now the equilibrium point is 4, comma, any of those two functions. Any of them, they have to be the same. Second and table, and I put in 4. And they have to be the same, 6.5, and they are. Okay, so now this, we're going to repeat the whole thing for the equilibrium point. So we're going to have the consumer surplus. This time is the 0 to 4. From 4 to 5, x squared minus 5.7x plus 22.5 dx, but minus 4 times this. And the producer surplus is 4 times 6.5. They are the same now because it's equilibrium point. The integral from 0 to 4, 0.3x plus 5.3 dx. And I'm going to do the same thing. Because these are polynomial functions, they're very simple functions, it's nothing sophisticated. So I'm just going to make minor changes here. So this is 4, and this is 6.5, and this is the same, but this is 4. So this is the producer surplus, which is $2.4. And then okay, so now I have 4. I multiply by 6.5. Good, same thing, but the integral from 0 to 4. So it's 27.47. And we know what the equilibrium point means, is when everybody's happy. It's where the demand equals the supply. So this is a quadratic function having a minimum, so something like this, but we are interested in 0 to 4. And the other one is a straight line. And that's all there is. It's where they're both equal, when the demand equals the supply. The number of units. Is this okay?
Question, actually.
Yes, please.
In the producer surplus on the other page, you got 6.2. Where
Yes.
did you get that from? I'm getting all the answers except for that. So that answer, I
You
got
have to plug it in.
43.
You have to plug it in.
I'm pretty sure I did, but okay.
No, maybe I made an error. Let's take a look.
Oh, maybe I probably was wrong.
No, let's take a look. Maybe I didn't enter it correctly. So I entered 0.3x plus 5.3. Is that correct?
Yeah.
0.3x plus 5.3. So then when we plug in 3, you get 6.2.
Got it.
It's okay, you know, I'd rather go back and check. Maybe there is something you see and I don't. There is no problem whatsoever. Good. Other questions? Anything else? Anything else? Okay, you can stop me anytime, as you know. So we are moving on to section 5.7, and we're going to talk about differential equations. Okay, so we looked at an example. Just to make it clear, we know what the differential equation is. It's an equation that has the derivatives in it. If it doesn't have derivatives in it, it could still be a differential equation, though. But it could just, I'm going to give you an example in a moment. So you can see how this looks like. Basically, chapter 4, everything chapter 4. So the two types of differential equations that we're going to look at are, number one, simple. When we talk about simple, we really mean chapter 4. That's all. We're going to look at examples in a minute. They may look differently, but this is all there is. Chapter 4, either definite or indefinite integrals. That's it. And number 2, there are many different types, but number 2 is the second one, and that's all we have to cover in this class. Separable differential equations. Let's start with the simple ones. And also let's go back and do one more example similar to what we looked at last time. So for example, I think we did 9 last time and I assigned 10. So let's do this time 11. So we are still talking about show that there is a solution, that this is one of the solutions. So in 11 we have the second derivative minus 2 times y prime, which is the first derivative, plus y equals 0. And they're giving us the function. We don't have to solve the differential equation. They're just giving it to us. And I just copied something else. Okay, so they're giving us negative 2e to the x plus x e to the x. Okay, don't copy this first one. So they're giving us a differential equation. How do I know it's a differential equation? It has derivatives in it. And they're giving us a function. And they're asking us to show whether this is a solution or not. It is a solution if it verifies the equation. It's not a solution if it doesn't verify the equation. So obviously, this is the function. But I have to determine the first derivative and I have to determine the second derivative. And then I put them where they belong. And if I get 0 on the other side, I'll say yes. If I don't get 0, I'll say no. So I start by finding the first derivative. Stop me if there is any question, please. Negative 2e to the x, that's nice. Prime is negative 2e to the x. However, this is a product. It has to be treated as such. Plus, the first function prime is 1. Plus, times the second one. Plus, the first function times the second one prime. Very nice. Negative 2e to the x plus e to the x. Y prime is negative e to the x plus x e to the x. So I have this, and now I have this. Now I have to determine the second derivative. Once I have the second derivative, then I will place them back where they belong and see if I get 0. This is the first derivative. I have to differentiate again. The first function, let me see the time here. Oh, I'm fine. So the second derivative now. Negative e to the x prime is negative e to the x. Again, this is the product rule. Plus, the first function prime is 1 plus times the second one plus the first times the second prime. These two go away. So the second derivative is x e to the x. Now I put them back. Back where? In the given equation. First, I have to start with the second derivative. I just did. X e to the x. minus. It says 2 times this. So 2 times negative e to the x is positive 2e to the x. And negative 2 times x e to the x is negative 2x e to the x. So I have this minus 2, I have this plus the function, which is this. Minus 2 e to the x plus x e to the x. So this is the second derivative. This is minus 2 times the first derivative, and this is plus the function equals, and let's see. If it's 0, then I'll go back and say it's a solution. If it's not 0, then I can't say that. The x e to the x with the x e to the x make 2x to the e to the x minus 2x e to the x are gone. 2e to the x minus 2e to the x. Wonderful. And that's exactly what I wanted to see. So I did get 0 after I calculated everything and I replaced them in the equation. I got 0. I will say yes. This function is one of the solutions of the differential equation that was given to us. So we haven't even looked at simple. We haven't looked at separable. This is just the introductory question. What was the question? Given the differential equation and the function, show whether this verifies the equation, in other words, is a solution, or it does not, so it's not a solution. Any questions on this problem? Please don't let me move on if you have questions. Okay. So let's move on to what I say simple. Here it is. Find the general solution, which is the most general antiderivative. And then find the particular solution, which is the unique function. Okay, so 5. You can choose always. Y prime equals 3 over x plus x squared minus x to the 4th, and they are telling us that y1 equals negative 4. This is 100% chapter 4. So I'm given the derivative. I'm asked to find the function, which is basically the most general antiderivative. So can anyone tell us what function prime is this? What function prime is this? What function prime is this? Anybody, please?
The first part would be 3 ln x.
Yes, the absolute value. Don't forget the absolute value. Very good. Plus x to the
X to the 3rd over 3, right?
very good, minus x to the 4 over 4 plus a constant c. This is what we studied in chapter 4. Nothing new. This is the most general antiderivative. Now they are giving us this piece, telling us that when you replace x by 1, the function value y of 1 is negative 4. This is negative 4 when I replace x by 1 all around, all the way. But 3 times natural log 1 is 0. This is 1/3. This is minus 1/4, and plus a constant c. So I move everything to the other side. So c equals negative 4 minus 1/3 plus 1/4. So again, we are told that the function is negative 4 when x is 1. Well, this is 0, this is 1/3, this is negative 1/4, and this is plus the constant c. To determine the constant, I moved everything to the other side. So I have negative 4, I bring a negative 1/3, and I bring a positive 1/4. The least common denominator is 12. So this one needs a 12, this one needs a 4, and this one needs a 3. Negative 48 minus 4 and plus 3 is negative 49 over 12. And I have to put it back in. The question was asking us two things, both from chapter 4. Find the most general antiderivative, and then find the unique function that satisfies this condition. When x is 1, y is negative 4. So we determine the constant. So now we have the unique function. What is the unique function? 3 natural log of the absolute value of x plus x to the third over 3 minus x to the fourth over 4 minus 49 divided by 12. So we answered both questions. What is the most general antiderivative?